We are going to continue working with exponents today. Sorry, I'm in a different room and it's kind of echoey in here. So I'm going to do the best I can to sort of make sure I'm speaking clearly. We're still working with exponents today. And as we are looking at exponents today, we're going to change it up a little bit. And instead of having a variable be the base, we're going to have it be a number, like an integer, okay, be the base. It could be any type of rational. It could be a fraction. Okay, but instead of it being a variable, we're now going to be looking at a numerical base. Okay, and here's the thing. The rules don't change, so I'm not really actually adding anything new today. However, because it's numbers that we know other properties with, we're going to want to make sure we pay close attention here because it's easy to make mistakes with these. So just like we've done before, okay, we're going to sort of go through those properties. So for example, multiplication for multiplying. We already know that if we have something like x squared times x to the third, we're going to add these exponents and we will get x to the fifth. So if we stick to that rule, and now instead of having x squared times x to the third, what if we have 2 squared times 2 to the third? Okay, if we want to do something like this, we're still sticking to that same rule. So we're adding the exponents. 2 plus 3 is 5, and just like up above, it was an x, it stayed an x. It was a 2, there is a 2, it stays a 2. So 2 squared times 2 to the third will give us 2 to the fifth. We do not want to multiply these two numbers because right here, the 2 and 2 are now acting as a base and not a coefficient, and that base is what stays the same. So let's say we have something like 3 to the fourth times 3 to the fifth. What would be our correct answer here? We should have picked 3 to the ninth, right? Our base stays the same. We add the exponents, and 4 plus 5 is 9. Now, you might say, why in the world would I need to do that when I can just evaluate them in a calculator? Well, yeah, but for example, let's say we're looking at division. Okay, what does our rule say we do with exponents and division? Right? Division tells us that we subtract the exponents. So if we have something like x to the seventh over x squared, well, 7 minus 2 gives us 5. So what do we think the correct answer would be if we have something like 4 to the ninth over 4 to the seventh? We should have picked 4 squared. Now, the reason why it's nice to know our properties of exponents is because to calculate 4 to the ninth, we're going to get a really big number, and then we're going to get another really big number, and then we're going to have to divide them. But if we simply know our rule to subtract the exponents, 9 minus 7 gives us 2, and we should know that 4 squared gives us 16. And so we can easily get 16 without even using a calculator. So if we have a power to a power or an exponent to an exponent, what do we do with exponents if we have 2 exponents happening at the same time? We should have picked multiply, right? We multiply them. Right, so we already know if we have something like y squared all to the third, we will get y to the sixth. So if we have something like 4 squared all to the fifth, we will get 4 to what exponent? To the 10th. Right? 5 times 2 gives us 10, and we should have picked 4 to the 10th power. Okay. Now, why this is useful again, so just like up here, right, we didn't have to do all of that additional work. We have that same idea that could happen here. So what if I have something like 4 to the 12th all to the 1/2. Then my student's like, whoa, wait a minute. We haven't talked about there being a fraction. A fraction as an exponent does not make any of those rules change. So if we have two exponents, we said we multiply them. So 12 times 1/2 would be 4 to the 6th. Now, negative exponents still function the same. Not a whole lot with that one. So if we have a negative exponent, since that's simply sort of just moving something around, my students tend to be more solid with that. But this is actually going to be something we use later in the trimester and we're evaluating. So if we have something like 5 to the negative 2, what does a negative exponent tell us to do? Right? It tells us to move it to the other side of the fraction. So we're going to take that base, which is 5, and move it to the denominator. And we know that 5 squared is 25, right? So 5 to the negative 2 would be 1 over 25. Likewise, if we're going in reverse order and we have something 1 over 2 to the negative 2, we should be moving this up. So what's the final answer that we would get? We should have picked 4 because we're moving this to the top, so that gives us 2 squared, and 2 squared is 4. Anything to the 0 power is 0. Adding when the bases are the same is kind of weird, so we're not really going to talk a lot about that. That doesn't seem to play as large of a role. So I just want you to understand that we can still use these properties even when we no longer have a variable as a base, but now we have an exponent as a base.